I've started the recording. Again, good afternoon, everyone. We are glad to have you on this session. This is our second session of this year 2026, and the goal is to share knowledge and empower each other as network engineers through this platform, the Life Technologies platform. And we are glad to always have you join these sessions. The last session we had Eve taking us through subnetting. Today we have Martin Modiva taking us through OSPF. Now we know that there are many protocols, and as a network engineer you are required to master many of these protocols. If you are managing a complex network, you will definitely have to master these different protocols that we deploy on different networks. I know many of us, we've gone through these protocols, not just once, but we have gone through them many times. We keep learning, we keep sharing the knowledge so that we can explore other features of these protocols. Some are deployed on our network, some are not deployed on our network, but it's a good thing that you should be knowing some of these features of the protocols which are not even deployed on your networks that you manage. Today we are glad to have Martin Motiva all the way from South Africa, who will be taking us through OSPF. Martin, I will bring you in right now so that you can take it over and start the session on OSPF.
Thanks, Martin. Before I continue, please do forgive me for the sound of my voice. I am recovering from a terrible flu. But before I start, let me first introduce myself. So my name is Martin Modiva. I'm based in South Africa, Cape Town. I am a senior network engineer working with the Cisco Nexus, Cisco Catalyst SD-WAN, and the VMware Velo Cloud SD-WAN. So today I'll be sharing with you the real world scenarios of OSPF and the principles of OSPF, including the mandatory configurations of OSPF and the optional configurations of OSPF. So I'm going to share my screen quickly. So I'm just going to give you an overview of the topology before I start. Can you all see my screen?
Yes,
Yeah, we can.
see your screen.
All right, cool. So my actual topology is quite big, so I've shrunk it a little because it will not fit here. So this topology is more summarized. So on here I have the customer's headquarters. So this will be the core switches, and these arrows here that are interconnected with each other will be layer 3 port channels. And then on the left here will be regional office 1, right, regional office 2 with a third party connect. And then regional office 3 is connecting through the MPLS, but how it connects to it, it goes through the service provider VXLAN, EVPN in order to get to the PE routers. And then the MPLS core will then take that traffic to the internet if required. So before I can start, do you have any questions regarding this topology?
I believe questions will come in as we progress.
All right, no problem.
Thank you.
All right, so do forgive me. I am a notepad person. I'm not really. I'm not a PowerPoint person. So do bear with me, new kid in the block. Okay, so I'm first going to start the with see someone's hand is up.
Hello, Martin. This is Yogesh. Uh,
Hey,
and hello everyone as well. I just would like you, if it's in your upcoming, you explain. Basically, what I would like is that you explain also the flow as well. Uh, Maybe before there, so we would have an idea of how the traffic should work for that customer. So
hey.
the customer flow, not just the infrastructure.
Oh, you're referring to this topology.
The flow of the customer, that is what I'm referring to. So for example, if the infrastructure is laid out and the customer is, for example, uh, getting his internet, all of his other sites internet from one of the branches, for example. Uh, so that is what I'm asking, that if is the flow on top of the MPLS infrastructure and this current setup.
Okay, no problem. Let me first start with the OSPF operations. Then, as soon as we get to the configurations, I will explain the deep dive flow.
Sure. Okay, thank you.
All right. So again, do forgive me. I'm a notepad person. So I'm first going to start with the OSPF operations. I have taken some notes. So the question is, what is OSPF? So before I start, I take it that all of you have a principal idea of what OSPF is. So OSPF is an interior gateway protocol open standard, meaning that all vendors can use it. Cisco, Aruba, Huawei, you name it. So OSPF is defined in RFC 2328, and that will refer to OSPF version 2 that's widely used. But OSPF version 1 is defined in RFC 1131, but that's not used anymore. It's an obsolete protocol. So OSPF is a classless routing protocol, and what this means is when you apply a network statement, you need to include a wildcard mask. So classless means that the actual subnet mask is exposed. OSPF does not have an official TCP port number, but rather a protocol number, which is protocol 89. So what this means is that OSPF will not populate in the control plane table because it doesn't have a UDP port or a TCP port. OSPF is a node-based routing protocol, meaning that it needs to know who is the advertising router, and it has a strict rule of the link state database to be in sync. So once the database is in sync, then there will be network reachability. OSPF is a link state routing protocol, meaning that it has the entire map of the network. And then OSPF uses link state advertisements to exchange routing information. And also link state advertisements are also used to know how to get to the actual advertising router as well, or routers. And then OSPF is a hierarchical routing protocol because it is design sensitive and it is scalable, and it does allow you to logically segment your network, unlike EIGRP, where it's quite a challenge to do that. But thanks to OSPF, It's now simplified. So OSPF uses the multicast 224.0.0.5. So then they'll be associated with the OSPF hello. All right. So now I'll go to the OSPF state types. So the down state is when the OSPF router is not receiving a hello message. So if let's say, yes, you may ask.
Yes, when you say OSPF is a link state protocol, maybe if you can just expound on that for us,
Okay.
the beginners.
No problem. So I will refer to I'll refer to first EIGRP. I like to refer EIGRP as a gossiper, saying, "Hey, I heard a rumor of that route over there. It has this metric because it cares about the reported distance." So OSPF is not really a rumor-based routing protocol, meaning that if I come to it and say, I'm trying to gossip area one, say, nope, you can't lie to me about area one. I already know about it. So you can't gossip. So meaning that it has the entire map or the entire topology. Martin, does that answer your question?
Yes, it does. If you can maybe also, I know that we have different classifications of these IGP protocols. You've mentioned the link state. There is also the other classification of the distant vector. So
Oh, okay. So you have the link state routing protocol, which is OSPF. You have the distance vector, which is EIGRP and your RIPS. You also have a path vector routing protocol, which is your BGP. So when it comes to I've explained the I've explained the distance vector routing protocol. So when it comes to the path vector refers to the AS hop when it calculates the best path, and also having the ability to talk to other AS numbers, whereby the link state and the sorry, whereby the link state protocol is more of an interior gateway protocol. Right, Martin, does that answer your question there?
yes, it does. Thank you.
Sorry for my cough, guys. This flu was terrible.
It's okay. We understand that.
All right. So I'll then start with the OSPF states. So the down state, as I mentioned, is when the OSPF router is not receiving a hello message. So meaning that the neighbor router is not sending a hello message with this multicast. So it will declare the neighbor as dead. And then the init state says that, okay, I have received your hello message. However, you have not included your router ID. So I do not know who are you. And then you have the two-way state. So the two-way state, it's when the two routers are negotiating the master and slave. So the master and slave comes in when there's a DR and the BDR. But when the network type is like point to point where there is no need for the DR and then the BDR, this state gets skipped instantly. And then you have your X start where the two routers are now negotiating the MTU size. So usually with the X start, if the routers are stuck on the X start, the Common reason will be the MTU size mismatch. And then for example, with the Nexus, if there's a subnet mask mismatch or IP address mismatch, the state will be X dot. So it depends on the actual platform that you're working on. Then you have your exchange state where now the routers will now start sending the link state requests, updates, and acknowledgements, including the database descriptors. And then this will be used to sync up the databases. And then the loading state, I'd like to call him as verifying if all databases are in sync. And then finally, it will be in a full state. So before I continue, does anyone have any questions about OSPF states? Yes, David.
Hi everyone. Hi Martin. Thanks for taking time to take us through OSPF. Now, I am one of those beginners Martin mentioned, and I always struggle with at what stage do we have the DR and BDR elected, and when they are negotiating master and slave. I mean, there's some literatures out there that really confuse. And since you were doing the preparation and you went through the RFCs for this one, could you one more time, sorry to take you back, but one more time, could you kindly, really explain what is the difference between DR and BDR election, and then there's also master and slave negotiation, and at what stage do those take place?
Okay, no problem. I'll explain to you with a nice paint. So I will refer back to, say for example, you have 4 routers. And let's assume that you have EIGRP running. So with EIGRP, all routers will pair with each other, meaning that it will form a full mesh. Now the problem with this is that if one router has a problem, you have a high chance of the entire network being stuck in active. And then with OSPF, I'm just going to draw the exact same topology. So with OSPF, say for example, you have these 2 routers. Here's an example. So all routers will have a priority of 1 by default. So meaning that the OSPF topology needs to elect a DR and a BDR. So a DR is a designated router that manages the OSPF updates. Say for example, if there's a topology change, the topology change will go to the DR, and the BDR will be on standby. So meaning that these 2 routers here, instead of forming a mesh topology, they will rather pair with the DR and the BDR, and then that way there will be full control. So say for example, this router here lose this link, he will send the update. So updates will be going around, and then the one who will be doing the answering. So picture this guy as a spokesperson. So he will say, okay guys, I have received an update from our good router here. I will then do the talking on his behalf. So that's the job of the DR. And then with regards to the DR and the BDR election, that will be in the two-way state. The two-way state, that's when the 2 routers have shared their router IDs, and now they will also look at, okay, so what is your network type? If your network type is broadcast, then a DR and a BDR is required. And then the master and the slave basically refers to, okay, the master will be the DR and the BDR will be the slave. David, does that answer your question?
Yeah, it does, Martin. But I don't know. I'm still getting confused because you find some literature say that yes, the DR and BDR will be elected or decided during the two-way state or stage. But now there's another concept of master and slave. I think they call it negotiation. I'm struggling to get that literature. Once I do, I'll share maybe after this call, where they say master and slave is determined during the extant stage. So that's why I was struggling with what's the difference there.
Uh, whose hand is up? Michael.
Michael.
Yes, yes, yes. Good afternoon, everyone. Actually,
Michael.
yes, thank you. Actually, I would like to help a bit on Martin to assist David to get a grasp on what he's trying to struggling with. Actually, can I proceed?
Yeah, sure. Go ahead, Michael.
Okay, thank you. Actually, David, this is how it is. Uh, doing OSPF as your dynamic routing protocol on your topology. For example, Martin has drawn there 4 routers, which means each and every router has to have a complete and equal routing table. I mean, OSPF table as each one in the topology. And in that case, mean each of the routers should be able to communicate with one another. So in real world implementation, making each router being able to communicate with another router, it is going to mean it is going to be a hectic part of process. So instead of each router going to communicate with another router in the topology so as to get and compare the routing table, the OSPF table with each other, they are electing one monitor, let's say, or maybe one head, let's say, let's give the name, and that one head or monitor will be able to connect with every router in the topology, and then you will understand that the topology to each router and share it to them to each other routers. So the router which is being elected as monitor or the head, that's the DR, and that one has to be elected in some procedures. I know Martin will explain. There are some parameters that will be used to select who will be our head or will be our monitor, and the BDR is the one who will be on standby in case the DR goes down. So with this say, it means the DR will be only the router having full adjacence with other routers, and will take the OSPF router from router A to share it with router B and C while itself keeping the routing table. I think I've tried to give you some how the DRR and the BDR are operating in terms of OSPF.
Thanks, Michael. That's a good explanation there. Yes, Anila, you have your hand up. Anila, you have your hand up.
Yes, can you hear me?
Loud and clear, sir.
Yeah, I hear that I'm not quite sure, but I didn't actually get the name of the next guy that was talking. Remember, we have a default priority, which is default priority 1, right? In all of our OSPF routers. Is that correct?
That's correct, sir.
Yes. Therefore, now, when the election takes place, the election of DR and BDR, how does that router, all these routers are default priority 1? How does the other routers, how does this one, the one that will become the monitor, what priority will be given to this one, and how does that priority gets to be given to that one? Because all of them, they by default, they have the very same priority,
Okay,
which is,
I
I just wanted
understand.
to give some that kind of explanation.
Sure, no
Thanks.
problem. Monsieur, let me answer Anela's question, and I'll come to you now. So, Anela, so correctly said, all the routers will have a priority of 1, right? So, how the election works is the tiebreaker will be who is the router that has the highest router ID. So, the router with the highest router ID will become the DR. Say, for example, it's this one. And then the second router that has the second highest router ID will become the BDR. But
Okay, that's
this,
clear.
so
Thank you so
so
much.
this, so allowing the OSPF routers to manually elect the DR and the BDR is quite dangerous, because sometimes you'll find that the weakest router has become the DR. Now you're gonna have problems in your topology. So by best practice, you rather want to give the strongest router the highest priority, and then the second strongest router, you can give it the second highest priority, and then these routers here will then become the DR other, meaning the designated router other. What that does is it says if he dies and he dies, then the re-election will then start. It will say, okay, so it's just me and you now. So between you and I, our priorities are the same. So now I'm still asking who has the highest root ID. Say for example he does, and he will become the DR, and then he will then become the BDR. Anila, does it answer your question?
Yes, now it's very clear, Mike. I mean, Martin, to me, because you have the question was based on how does it get to be the DR. So you told me that it based it's more like the same as your spanning tree, the one with the ice make address and the priority like that. Okay, I get that. Thank you so much. It's
Sure.
very clear, because I was not sure if because they both have the very same priority. Now that you have explained to me that it looks at the way with the one with the router ID. So yeah, makes sense.
Sure, no problem. Mansoor?
Hello, am I audible?
Yes, loud and clear.
Yeah, so I just wanted to add to what I think Michael when he was explaining to David the DR and the BDR. So you can think of it as a instead of all the routers flooding their updates to every single router, you just elect a leader who has visibility. In fact, they all have visibility, but then any change that happens to the network in the network is sent to the leader, and then it's replicated and sent to every other router, because OSPF is very CPU intensive. So it's just like, I mean, saving CPU cycles and then optimizing the protocol kind of a way.
Correctly said, Mansoor. Thanks for that.
Hi, Martin. I think you can just proceed. If there's still time, I think I may need some 2 minutes to clarify what I need, because all of you are explaining what exactly it is, but my challenge is on the two concepts: master, slave, and DR and BDR. So just proceed. Then, if we have time, we can touch up on that, because it will take about 2 minutes to understand.
Sure, no problem.
Yes, Martin. Just sorry to interrupt. So, guys, we will take a different approach. I know you have many questions, many burning questions that you have after Martin has presented on these subtopics. But to save on time, please use the chat to ask your questions. And then later, once he has completed the presentation, before the lab, we can respond to those questions and then proceed to the lab. So just take note of your questions, send them on the chat, and then we will respond to them before we start doing the lab. Thank you. Martin, you can continue.
Thanks, Martin. All right. So I was at the X start. So what I'll do, I'll just restart here from the two-way state. So the two-way state, and as I mentioned, it will be the master and slave negotiation, and DR and the BDR. And again, this only comes in if there's a need to elect a DR and a BDR. If not, then this stage will be skipped with immediate effect. And then the X start state, as I mentioned, it will negotiate MTU size. So if the two routers have an MTU size mismatch, the state will be on X start state. And then when it comes to the exchange state, that's where now the OSPF link state requests, updates, and acknowledgements, including the database descriptors, are then shared to help both routers to sync up the link state database. The loading state, as I mentioned, that is more of making sure that nothing is missed, filling in the missing gaps, and then finally it will be the full state. Now going ahead with the OSPF packet types. So the first packet type will be the hello message. The hello message simply says, "Hey, are you there? Hey, are you there? Hey, are you there? Can I still keep the adjacency up?" And then the database descriptor is more of what is the LSA associated to. So the LSA will be associated with the advertising router ID, and then it will also represent the database descriptor, which OSPF uses to sync up the databases. And OSPF uses that to make sure that both routers have the same descriptors. Now you have your link state request saying that, hey, I have my link state database. I'm sharing it with you. Can you please give me your link state database so that I can say I can make sure that we are both in sync? And then the link state update says, okay, I have received I have received your link state database, and I mean I have received your link state request, and I'm going to update you with my link state database. My apologies for that. And then the link state acknowledgement will say, okay, so I have received your link state database. I'm sending you an acknowledgement to show you that we are both good. And then I'll then go to the OSPF area types. So the first one will be the backbone area, which is area 0. So the area 0 will be the center of the OSPF fabric. Then the standard non-backbone area is a non-backbone. It's, for example, you can say area 1, area 2, area 10. And those areas are not special areas. They are not stub areas. They're just normal areas. And then your stub area simply says that I am going to suppress your LSAs to reserve resources, because with OSPF, it can be a beefy protocol, especially if you have a router that's receiving LSAs that it does not need. So let me show you an example here. So say for example, you have the backbone area, you have area 1, and you have area 2. So say for example, this area here has LSA type 1, type 2, type 3, and then you have your ABR here. Type 4 will then be generated by him, then finally type 5. But now area 1 is a small site, for example, and it doesn't really need all LSAs. It can simply live with the default route. But sometimes you may think that, okay, I can use a prefix list to filter out routes and then just allow the default route. So basically what you're doing, you are saying, out of my database, I will take the default route and I will allow it to be the one that propagates in the routing table. Yes, that partially fixes the problem, but you still have your link state up, your LSAs coming in, which are resource intensive. And then that's where your OSPF stub areas come in. And then you have your not so stubby. I was supposed to put this here. My apologies. There we go. So the not so stubby, it operates just like a stub area. However, with the not so stubby, it has redistribution privileges. So again, back to my drawing here. Where's my drawing? There it is. So area 2. So with area 2, say for example, you have a router here, and then let's say now this company has purchased another company, and then that company happens to have a router here. And this router here is running EIGRP as an example. And then you already elected this route. Let's say, for example, this route is in a stub area, just like area 1. The problem with the stub area is that it does not have redistribution privileges. So that's where now the not so stubby comes in. So the not so stubby says, okay, I will still suppress the LSAs that aren't required, and I will still give you the privileges to redistribute. But how it works is that going back to, let's say there is no stub and not so stubby. If you redistribute coming from area 2 as an example, what's going to happen is that the area border router will be required to generate an LSA type 4 back to area 0 to say that, hey, we have an ASBR coming from area 2, and this is how you need to get there. But now the problem is that now you have generated an LSA that in that area 0 that doesn't really need. So to optimize that, rather configure a not so stubby. So a not so stubby says, okay, area 2, you don't have to generate an LSA type 4. Why? Because on here, I will generate an LSA type 7. And by the way, LSA type 7 is not allowed to exit an area, but it will be translated. And how it's translated, it will use what you call a P bit or a propagate bit. A propagate bit says, I will take an LSA type 7 and I will translate it to an LSA type 5 and then send it back to area 0. Then area 0 says, okay, I understand. So picture this process as net. All right. So, and then totally not so stubby works just like not so stubby. And now the question is with the stub area, which LSAs are suppressed? So I'll just type here stub area LSA suppression. So the first LSA that is suppressed, we're talking about LSA 4, and we're talking about LSA 5. And then if we go to the not so stubby, the not so stubby will still be LSA 4 and LSA 5. But now if you go to the term totally, which exists in stub and not so stubby, the extra LSA that's suppressed will be LSA type 3. What this means is that the specific routes that are coming from LSA type 3 will be suppressed, and the default route will then propagate with that LSA type 3. Same applies with the not so stubby. But the benefit of not so stubby is that now you have the default route control. So let me go to this topology here. So say, for example, you say, you know what? Let's say we want this third party to use their own default route. We do not want to give them a default route. So now the not so stubby will now give you that privilege. Will say, okay, I'll put you in a not so stubby, but I will not advertise a default route to you. And then if you go totally simply says, I will advertise a default route to you unconditionally. All right. Do you have any questions? All right.
Yes.
So yes, sir, go ahead.
The question would be, I'm not quite sure whether I'm taking you back, but it's something that you can just put down maybe after the session. You can just clarify. It's between stubby and not so stubby, right? I might be wrong in this. Are you saying no so stubby works hand in hand with ASPR, and stubby works hand in hand with APR? Remember, I might be wrong again. Remember, if you have your EIGRP or BGP, it will be on your ASPR, right? Your risk distribution will be on your ASPR. So are you saying to me now, not so stubby works with ASPR and stub works with APR?
No. So let me explain it differently.
Okay.
So we have area 0. As a matter of fact, let me rather take a snippet and then I can explain it this way. I think it'll make it easier. There we go. All right, so this will be your area 0. And then these two guys here will be your area border routers. So the not so stubby being on this side, what it does, if EIGRP routes are imported into OSPF, it will generate LSA type 7, right? That LSA type 7 will be sent to the area border router. The area border router will translate the LSA type 7 to LSA type 5. And the reason behind this, it simply says, I will simplify the LSA process. I do not have to generate an LSA type 4 for area 0. So meaning that the guy who does all the work will be the ABR for all the stub areas. And then going back to the stub area, the stub area will also be managed by an area border router. And the area border router will say, okay, I will generate an LSA type 3 and I will send it to this area. And when this guy sends routes to me, I will see those routes as LSA type 1 because these two links are part of the same area. But as soon as I send the routes coming from this area back to area 0, they will not be seen as LSA type 1, but rather be seen as LSA type 3, telling area 0 that, hey, these routes are coming from another area, and if you want to go to that area, you need to go through me. So picture this guy as the security guard saying, if you want to go through me first. Does that answer your question?
Yes.
Okay. All right. So now let's then go to what is required to form a successful neighborship. The areas, yes, definitely they need to match. The subnet, yes, it needs to match. The stub flag, it needs to match, meaning that if I go here, if on this side, if I have area 1, but on this side I configure area 1 stub, the adjacency will not come up. So the stub will be the flag. So both flags needs to be identical, but not in a sense of if I come here and say you are a totally stubby area, that doesn't mean that I need to do the same here. On here, it will just be a simple area 1 stub, whereby he will be the master of that area. And then the authentication must match, meaning that the authentication type must match, the authentication key must match as well, and the key number. The MTU size must match. However, you can override this, but not really recommended. If you do it, the adjacency will come up, but you will start receiving complaints of your customer, which is your users, saying that, hey, we have slow performance, hey, we have packet loss, etc. So short answer is don't do it. Don't do it. If you have a scenario where one MTU size cannot be matched with the other, I wouldn't recommend you to run OSPF. David, let's see. Please clarify between neighbor relationship and adjacency. Yeah, sure, I'll get there. And then the hello and the dead, meaning that the hello timer and the dead timer needs to match. So now let's dive in deeper in these negotiations. So if I go to my drawing here, so I have two routers, and say for example I'm using MD5 or message digest 5. So with the message digest 5, the key number must match and the actual password must match. But before you even get there, the hello message of the 224.0.0.5 needs to be allowed. Now say for example you have layer 2 links here, layer 2 nodes here. So with these layer 2 nodes, it will so basically if let's say these layer 2 nodes have some sort of ability to block this, then you will start to have OSPF related problems. It's unlikely. So, but a hello message needs to be sent first before getting to this point. And then once hello messages are being sent, they will then say, okay, so what is your timers? So say, for example, you have broadcast. If it's broadcast, the hello will be 10 and the dead will be 40. And which means that it needs to match here as well. But say, for example, you are in a scenario where the network types don't match. Say you have broadcast here and then you have point to point here. So the adjacency will not go down because point to point still uses 10 and 40, right? But you now going to have a root exchange issues because now one router says, I do not understand what you're saying because I need to now generate LSA type 2 and I need to send it to you. But the point to point says, I am not using LSA type 2. So if I send you that message, he will say, but I'm broadcast. I am broadcast. Sorry, man. I'm missing stuff here. Sorry. So with the sorry, with the LSA type 2, you will see it in your serial links. My apologies for that. So with your serial links, by default they will be point to point. So if the network type is point to point here, LSA type 2 will be sent out to router 1. Router 1 says, I'm broadcast, I'm Ethernet. I do not understand LSA type 2. So I will not be able to sync my database with you. So meaning that the adjacency will still continue, but router 1 will not see any of the routes coming from router 2. Are there any questions before I proceed? No questions? Okay. So let's go over to the LSA types. So the LSA type 1 will be the LSA that says, hey, I am router 1. Here's my router ID. I am talking to you. I'm also using that LSA to send out the hello messages. And then LSA type 2 will be the LSA that negotiates network, meaning if you have serial links, then automatically an LSA type 2 will be generated. But if you set the network type 2 to point, then LSA type 2 will be generated. But I do not want you to think of point to point as the subnet mask of /30. No. So OSPF does not dictate its network type based on the subnet mask. No. It dictates based on the technology that you are using, or the link, or the actual link type. And then you have your LSA type 3, which is your inter-area routes. So the inter-area routes will be routes that are coming from another area. Yes, David?
Sorry, Martin, I keep taking you back, but could you kindly clarify on LSA type 2? Because for point-to-point connection, there's no need to elect a DR and BDR. And in my understanding, type 2 is generated by a DR. So will there be a type 2 in point-to-point?
So point to point, if let's say going back to ancient links, let me do this. If you have router 1 and router 2, and let's say you're using a serial link, meaning if we go back, it's classified as T1 links. So if they classified as T1 links, these links, they do not broadcast. So when they don't broadcast, automatically they will become they will be seen as point to point. So if it's point to point, an LSA type 2 will be generated. Uh, does that answer your question, David?
No, it's still confusing the question because I don't think we have LSA type 2 in point-to-point connection.
Okay, no problem. We will come back to that. I may be missing
Let's
it.
proceed. Yeah, it's okay.
Yeah, no problem. Please do bear with me. I'm not doing this every day.
No, it's
I
fine.
do,
We're here to learn and share knowledge. No worries.
yeah, I do apologize if I stutter from time to time. Okay, so and then you have your ASBR summary. So the ASBR summary says, I will tell you where the actual ASBR live. I will use this LSA to advertise the router ID of the ASBR. So the type 4 is not really a routing LSA, but rather a reachability LSA. So the question is, who will generate this LSA? It will be the ABR, but we will get there. And then you have external LSA, which is type 5. The type 5 will be the LSA that manages the routes that are coming from a non-OSPF domain, like your BGP, like your OSPF. And then for your LSA type 6 will be your multicast LSA. So this LSA is obsolete. This LSA used to do the job of PIM or your protocol independent multicast. But now that PIM is in the picture, LSA type 6 is no longer in use. That's why it's obsolete. And then with LSA type 7 will be your not so stubby area that will represent an area type that is stub that has redistribution privileges. And then with LSA type 8, that will come from OSPF version 3, where instead of using LSA type 1 for hellos, it will then also use the link local of IPv6 to do the same job as LSA type 1. And then LSA type 9 will be your traffic engineering and LSA, mostly used in the MPLS environments. I haven't seen these in action. I haven't seen companies using these LSAs. Most companies that I've seen in the service provider environment, they rather want to use ISIS. And then let's then go to the hello and the dead intervals. So as I mentioned, the broadcast, the hello is 10 and the dead is 40. Point to point will be 10, 30. Non-broadcast, meaning that the hello message is the multicast is not on automatic. So this will be for your NBMA networks. So that means that instead of relying on the automated hello message with the multicast, you will then use the neighbor statement within OSPF, and I can demonstrate it. So the hello will be 30 and the dead will be 120. Point to multipoint, common in DMVPN networks, also 30 and 120. Before I proceed, do you have any questions regarding the timers? Yes, you are correct. I did miss the LSA type 2. Do forgive me for that. I do accept that I was wrong there. David, my humble apologies there.
No worries, no worries. Thanks, Eve. Thanks, Martin.
Okay. And then let's go to the OSPF router types. So you have your IR, which is your internal router. Internal router, it's simply a router that has interfaces that all belong to one area. An ABR will be a router that has interfaces that are connecting to a non-backbone area and interfaces that are connecting to the backbone area. And then your ASBR will be the router that brings in OSPF. I'm sorry, then that brings in non-OSPF routes into OSPF, like for example your BGPs, your OSPFs. Your EIGRPs, etc. All right. That is that. So now, before I go to the demonstration, are there any questions before I can proceed?
There is one in the chat, a very important one from Dan.
Oh, these timers are default. Yes, they are default.
I have a question, please.
Yes, sir, go ahead.
Thank you for your presentation. What is the information that the LSA hold? What types of information?
So the LSA simply says, I will include a database descriptor, and I will include the advertising router ID.
Just
Yes,
database description and router ID?
yes, I can demonstrate it to you now.
Yes. What about this subnet mask and IP address?
Well, that depends on the LSA type that you're referring to. If let's say LSA type 3, it will show the actual routes that are part of that LSA. And but what's critical about those LSAs is that the database descriptor and the advertising router ID needs to be part of the packet. If not, then it will regard that node as not reachable.
Yes, thank you so much.
You're welcome, sir. Any other questions?
Martin, there was one about the timers, and someone asked if you can change them.
Yes, you can change the timers. You can. All right, so I will. Yes, is there a
Yes.
question?
How many routers in each area? Maximum router in each area?
Well, in the olden days, it was recommended that an area must not exceed 50 routes.
50?
50, yes, but
Not 256.
no.
Wrong.
But
Okay, in contrast, ISIS can hold more than 50 routers.
yes, ISIS can have more than 50 routers. Yes.
Why?
So remember that ISIS is a layer 2 protocol.
Layer 2 protocol.
And then with the amount of routers that are involved, it will also stipulate the amount of routes that are being propagated.
ISIS is a layer 2 protocol, not routing protocol.
Yeah.
Please, can you understand this point, please?
Oh, there's background noise. I'm struggling to hear you, sir.
Can you understanding me this point? ISIS, why this protocol considered layer 2?
Are you asking, is your question relating to why ISIS is more more
Is layer 2, is layer 2. Why ISIS layer 2? Lies in
so
layer 2. Why?
so with ISIS, the reason why it's layer two, it's based on the peering principle. So if you go to the ISIS database, instead of showing layer 3 information, it will rather show your layer 2 information.
Which is better, ISIS or OSPF?
It depends on what you're trying to achieve and where you want to apply it. But
In, in ISP, in IS Internet Service Provider, ISIS is much better OSPF.
yes, ISIS is considered to be the preferred protocol because it does not have those strict principles of the area must be strictly connected to area 0. So with ISIS, there is no need for that. And then the configuration is cleaner as well. It is recommended for the Nexus environment when you want to run your BGP EVPN using ISIS as an underlay, and then with the MPLS core as well, using using ISIS as an underlay and then BGP the overlay.
Thank you. Thank you.
You're welcome.
We need the other meeting for ISIS.
Sure, no problems. Anela, you may ask.
No, what I was going to say, it's a this is becoming very difficult to understand what you guys are talking about. There's someone that is having noise in the background, so we can't hear anything that you guys are trying to explain to one another, of which it could have also assisted us as well. So
Okay, no,
we can try to talk that.
okay. Who is on mute? Zohir, you may ask.
Yes, could you explain the second point? Because we can use OSPF as well on top BGP, we can use on top OSPF as well. So why ISIS preferred in ISP? The second point you were referring to.
So the short answer that I'm going to give you is that ISPs prefer ISIS over OSPF because of design limitations and design restrictions.
Are you referring to the 50 router in an area design restriction or something else?
No, not quite. Design restrictions in a sense of a non-backbone area to be able to exchange routes with other areas. It needs to be strictly connected to area 0. So with
Yes.
ISIS, that is no longer required. If there aren't any questions regarding OSPF, I suggest that we continue. Unless there are other questions regarding OSPF. I understand you're asking about ISIS, but let's be fair to everyone and stick to the protocol that's discussed. All right. No problems with uh, okay, so then I will go to the actual topology. So this will be the actual lab that I'm referring to here. So what's summarized will be the MPLS core. So the MPLS core, as I said, is running OSPF. And then this will be the Nexus 9K that's running OSPF in the background and BGP. And then this will be the customer side, but my focus will be on the customer head office switches, regional office switches, and the third party. Anele?
Sorry, Martina, just by mistake.
Okay, no problem. So I'm first going to now log into the switch here. But how I log in, I first log into the management box from my home network, and then from there it will take me straight to the lab network. Right. Oops, wrong username. There we go. All right. So I'm first going to start with the configurations. Some of the configurations will be optional, not really required. So if I type in show run pipe section router OSPF. So as you can see here, I've got area 1 that's configured as a totally stubby area, and area 2 as not so stubby. And then the timers don't. So with these timers, they're not timers that are used for adjacency, but these timers are rather used for what you call the OSPF PRC, or the partial routing calculation. So that is optional. It's not recommended that you mess around with these timers because they can cause havoc in your network. Use them when you need to. All right. And then if I go to show IP OSPF interface brief, so you will see that the two loopbacks, the network state is stated as loopback, and then he'll be stated as DR, and then the rest will be stated as point to point. Now, what I'm going to do is I'm going to clear the OSPF events and the process just to see in the background how are the LSAs shared. So I'll put in clear IP OSPF events, clear IP OSPF process. I'll say terminal monitor. I'll say debug IP OSPF hello. So with the hello, notice that hellos are being sent and received, and they are using this multicast address here. And then I'll say you all to stop the debugs. I'll put in debug IP OSPF adjacency. So with the adjacency, that's where we see the nitty-gritty part of things. So if I put an IP OSPF process again, that's where now we will see what's really going on. So if I go all the way up, and yes, there we go. So as you can see here, that the two-way state simply says that, hey, I have received your hello message, but because this neighbor here is not part of the DR and the BDR process, so there is no need to negotiate for the BDR. So now it will not attempt to negotiate slave and master. And then going ahead with the show IP OSPF events LSA. So here you'll see how the LSAs are generated And then on here, based on, I think it was what's his name again? Zohir, not mistaken. Yes, Anela. Anela, go ahead.
I just want to know, is this being recorded though? Okay.
Yes, it's recorded, Anela.
Okay, cool.
Please, sorry to interrupt, Martin. Let's use the chat, please, for such questions so that we save on time. We only have like 30 minutes to go, so
Okay. All right. So as you see here with LSC type 1, it says, okay, this is my local router ID, and this will be my associated database descriptor, which you see here, and also part of the area. And then looking at the rest, this will be the actual route that's associated to the LSA type 3, and also with the database descriptor. But to have a clear view of the database descriptor, it will be the show IP OSPF database. So this will then give you a wider view of the database itself, and this will be the database descriptor. But now let's now break this network for a sec. So let me do this quickly. So I'll go to the second core switch. So I'll say show IP OSPF interface port channel 1. And in port channel 1, we can see that it's point to point, and the hello is 1040. So let's break this guy for a sec. So I will go to interface port channel 1, and I'll put in IP OSPF hello. So if I put in 30, by default, the dead will be 120. And then if I go to show IP OSPF interface port channel 1, notice that I only put 30, and then the dead is 120. But the label will not go down immediately because it now needs to wait for the whole time to elapse. But I'm not patient. I'd rather want to kill it. All right. And then when there is a timer mismatch, you will not see it in the neighbor statement. How you will find it, you'll rather find it with the debug. So it'll be debug IP OSPF hello. So with the hello, that's where you will then discover that there is a timer mismatch. There we go. So now port channel 1 has received the hello, but it says, whoa, our timers do not match. So then when it's like this, let's say, for example, we go to the other side, and then I go to interface port channel 1, IP OSPF hello, I'll say 30. So if it's 30, the dead interval will be 120 by default. So show IP OSPF interface port channel 1. So the hello will be 30, dead will be on 20. So when it's like that, then OSPF should then come up. So if I if I bring back the hello messages, so it's no longer complaining. Now the OSPF is up and running. So now let's break the let's break something else. Let's break the area. So if I go to interface port channel 1, and I say IP OSPF 100 area 100. So he will immediately say, hey, there's a area ID mismatch from the backbone. And then when it's like this, without the debugs, you will see this as alerts. So then if I then come here, say for example, we do not know what is the source area. So I'll put in debug IP OSPF hello. So notice that because now there's an area mismatch, he doesn't want to respond to the hellos because he says, wait, but we are not in the same area, so I won't be able to talk to you. So then if I go back, that's where we will then see where's the source of the problem. So if I go back and rectify the area, IP OSPF 100 area 0, and then it'll come back online. So now let's go ahead with the authentication. So with the authentication, this will be the authentication type, which is the message digest. And then the message digest key needs to match. So say, for example, I come to this interface and I apply IP OSPF message digest key 20 MD5 Cisco. So basically what I am breaking, I'm breaking the authentication process. So if I put in clear IP OSPF process, show IP OSPF neighbor. Oh, he's up. Did I break it well? Let's see. Oh, okay. So it did not override this. Okay, my apologies. So I'll go to this guy, negate him, and clear IP OSPF process. And then yes. There we go. So he is broken. So so now what I have applied here, I have caused a message digest key number mismatch. So now, although the password is correct, but the key number needs to match as well. So if I put in debug IP OSPF hello and IP OSPF debug IP OSPF adjacency. There we go. That's what I want to see. So basically, he will say, buddy, I'm sending you hello, and I'm trying to tell you that my authentication key number is 1, but it doesn't match up. So if I go to the other side, let's kill all of these debugs. I put in debug IP OSPF adjacency. And then on this side, we will not accept. We will just send because there is a mismatch. So if I go back and I can rectify it. So I will put an IP OSPF message digest key 1 MD5 Cisco and clear IP OSPF process to allow it. Ah, there he is. All right. If I go to show run, so notice that I have two numbers here. I have 20 and 1. So because switch 2 is negotiating with key 1, key 20 will be ignored unless on the other side the 20 is now used. So say for example I go to the other side and I apply 20. So I'll go to interface port channel 1. No, let's say IP OSP. Actually, I'll just negate this one. I'll put in IP OSPF message digest key 20 MD5 and that'll be Cisco. Then I'll see clear IP OSPF process. Yep. So now, come on, no, stop. So now, because now on the other side, the switch says, okay, so the key that I have, then the first key that I have used, which is this one here, I will continue with that key because as you can see here, I did not clear the IP OSPF process on the other side. I've cleared it on this side. So it's receiving a complaint that, hey, your key does not match. So I will rectify it. So I'll put in no IP OSPF message digest 20 M. There we go. IP OSPF message digest 1 MD5 Cisco. And again, clear IP OSPF process. And yes, so we have a successful neighborship. So now let's then break the MTU. Let's see on this side, before I apply it, let's check what's the current MTU. So the current MTU size is 1500. So I will apply IPMTU 1440. I'll apply clear IP OSPF process. And then being it said, if I type in show IP OSPF neighbor, notice that he is stuck on X dot. So now it's quite, so in this state, let's say, for example, you're called in and you've been told, hey, OSPF is down and you see X dot and you don't want to play the guess game. Rather, let's check the debug and see what is it complaining about. So I will put in debug IP OSPF, and then I'll put in the adjacency and the hello. There we go. That's what I want. So notice that he is complaining that, hey, we are receiving a higher MTU than what we have locally. So now to resolve that, it will be IP OSPF MTU ignore. But doing this, I do not recommend it. As I mentioned, so if you have MTU size mismatch between the two, it's going to impact your applications. So on the network posture, you won't really face issues, but you'll start to receive complaints. So the short answer is don't do it. All right. I know I'm moving a bit fast. Do you guys have any questions? I don't see any questions in the chat. Yes, Nick.
Yes, so you said regarding MTU, can you please go back to the part of the debug where you said showed X dot?
Oh, okay. So let me go up. You're referring to this output.
Yes. So show IP OSPF neighbor. What does that mean on that interface port channel one?
So the the X dot it simply says whatever that I'm trying to negotiate with the neighbor that's coming from port channel one, we don't seem to agree with one another.
Okay.
And then assuming that we are brought in the network and we're trying to troubleshoot what might be the problem, then that's where we now running debugs. So then if
And
I
that's
go,
where you saw the MTU.
yes.
So there's
So
an MTU mismatch. So how do we? Oh, sorry.
no, go ahead.
Okay. So since you don't recommend ignoring you don't recommend that OSPF should ignore the MTU mismatch. So what other resolution, if I could say, because you said that can affect our applications, right?
Yes.
So what other proposed solution do you think, like to get the MTUs to match?
Well, so the question will be, what is your link type, and what is the supported MTU on that link? So let's say, for example, if I go back to the topology, and let's assume that it's from this router to this Nexus 9K as an example. Let's say this Nexus 9K is connected to a layer 2 device here that can only go up to 14, let's say 1438 MTU as an example. So in that case, the resolution is to apply the maximum segment size, and what that does, it tells the router, hey, reduce your chances of fragmenting your packets. And let me show you why I say that. So I'll go to the third party router. It'll be 3 1 yeah, there we go. So if I type in show IP traffic as an example, so the IP TCP MSS will say, okay, so make sure that this router does not cause fragments. Like for example, here, the reason why there are fragmentations there was because I was running ping tests that were above 1,500. Now the problem with packet fragmentation is that with sensitive applications that is not immune to fragmentation, like your CAP web control traffic, your HTTPS traffic, your browsing traffic, that will break. you'll start to hear complaints that, hey, the browser is just spinning with no success. And then the AP will just say, hey, I'm trying to talk to the controller. The controller is sending traffic back, but it's fragmenting. The AP will then get a packet that is corrupted. Does that answer your question there?
Yes. Yes, that does make sense.
Okay.
So the answer would be to set the MTU size to its most maximum size in order to reduce fragmentation.
No. So if you there's no need to change the MTU size per se, unless you have a tunnel to accommodate the tunnel headers. But if it's just pure Ethernet and all that, it's not critical to change
Yes.
the MTU, but it's rather critical to set the maximum segment size to also help with to not
Okay.
push the router to not fragment. The other solution to that is to enable the DF bit. The DF bit will be your don't read defrag bit. The problem is that the router will start dropping packets if it exceeds the MTU. So if you ask me, I wouldn't enable the DF bit.
I see.
Okay.
Okay,
So then
understood.
no
Thank
problem.
you.
So then going back to our switches. So now let's break the subnet mask. So we have a /30. So I will go to here and apply 10, 100, 1.1, 255, 255, let's say 248. It overlaps. Just trying to find a subnet mask that might. No, it's going to overlap. Okay, so I won't be able to demonstrate that because it's going to cause overlaps. So basically, when I apply it, it's going to complain about the subnet mask mismatch. So now, going back to the OSPF configurations, let's now break the stub area flag. So if I go to router OSPF and remove area, I'll say area 1 stub terminal monitor, and I'll put in debug IP OSPF hello. And then let's just clear the process. Here we go. So what I'm looking for is this. So now port channel 3, that's going to regional office 1. So if I go to the topology, it will go to the switch here. And in the summarized diagram will be the switch here. And I'm in the switch as well. So he is complaining that the stub area flag is mismatched. So if I type in show IP OSPF neighbor, I will not see this guy as the root ID in the neighborship because the requirements are not met. So I will go ahead and fix it. I'll put in IP, not IP OSPF, area 1 stub. And then there we go. But what I wanted to show you regarding the stub, so let me go to the regional office 1. So that will be 201. So if I type in show IP OSPF events LSA, the totally stub area, meaning that if I type in show IP route, I will receive a default route, and that default route will be tagged as LSA type 3 because of the stub type. I will also receive I'll also receive I will receive the reads that are coming from that specific area in inter domain area. Sorry, inter area route. Sorry, not thinking straight. Sorry. So if I type in show IP route here as well, notice that I am receiving inter area routes and with the default route as well. So if I go back to the core switch and remove the stub area and then reinstate it, no IP OSPF, sorry, no area 1 stub and area 1 stub, no summary. So if the minute you say no summary, that is when you say the area is a totally stub area. So if I go back in here and I say clear IP OSPF events and then clear IP OSPF process. So I'll put in show IP OSPF events LSA. So notice that now we are not receiving all of the LSAs that we used to receive. Now we are receiving only the default route coming from core switch 1 and core switch 2. And the question is, how will the database look? So I'll type in show IP OSPF database, and there you have it. So only the default route. And if we go to the actual RIP table, if I type in show IP route OSPF, only the default route is propagating. So now let's say there isn't a stub area. So I'll go to route OSPF and say no area 1 stub. So break, but let me go fix it the other side. I'll say no area 1 stub. And then I'll say clear IP OSPF events, clear IP OSPF, not database, process. And I'll type in show IP OSPF events LSA. Then notice that now we are receiving all of the LSAs now. And boom, notice that now we are also receiving the LSA type 4, the LSA type 4, saying that, hey, these guys, they are your autonomous system boundary routers. And that's how you get to them. So if I type in show IP OSPF database, so I notice that now your link state database now has a lot of information here. But let's say now we prefer not to use the LSA suppression, but rather to use a prefix list. So I'll go to the configuration. I'll put an IP prefix list, and I'll just name it OSPF in. And I'll say sequence 1, and I'll permit quad 0/0, and I'll go to the OSPF. I'll say distribute list. I'll say prefix, and I want to call out the OSPF in, and I'll stipulate the direction in. So if I type in show IP root OSPF, I'm receiving the default route. But now if I type in show IP OSPF database, notice that that doesn't clear the database itself. So what I'm simply stipulating, I'm saying that out of the database, I'm only interested in this route. So this doesn't really save your resources because your router is still managed, is still required to manage all of this information here. So hence you have your stub areas coming into play to save resources. All right. Any questions? Yes.
Alrighty. Quick one. So I just want to ask this: what's a reasonable amount of a LSDB size that you think it's a fair size within your OSPF domain?
Sorry, please ask again.
Um, what would you recommend as a reasonable size of your LSDB within your OSPF domain? For the reason I'm asking is that I run like a large, I can call it a large ISP. Then obviously I got OSPF. So let me give you a bit of an idea. So I got some pops and I got the broadcast back to the DC. Then the pops are linked to other nodes which got OSPF. We can say like I got probably 400 routers on my OSPF domain. Okay. And obviously it's a resource. We're talking about the resource consumption here. And at some point we had like bad experience and stuff because of the size of LSDB. That's why I'm asking, do you have anything in mind in terms of like your size of your database?
So the size of your link state database will depend on how many areas do you have, your overall.
So this is but funny. So it's a network actually. I found how it was built. So there was no areas as well, and obviously I took a different approach, which is not always on OSPF side. So my approach was because of the LSDB size that's increasing continuously and we're expanding and so forth. And I built like some route reflector into a network so we can carry our prefix with not within an OSPF domain. So that will minimize actually the amount of routes which I'm injecting into my OSPF. So I've got like IBGP now, right? Currently, I got like a mesh kind of route reflector, and segregate them per region, so I can inject those routes into the BGP instead of having it OSPF. So my OSPF, but this is a plan. It's still, I think it's like I completed 30%. So the main idea here is that to use OSPF only for reachability, not to inject prefixes because of the size of the network.
Okay, so what you're basically saying, you're saying that using your OSPF as your underlay, and then BGP as your overlay.
My overlay, yeah.
So with your environment, since you're running BGP and you are using your loopbacks as your source interface as well.
Yeah.
So you want to suppress your transit interfaces, right? So your transit interfaces will be interfaces that are actually used for the hello process. They still participate, they still allow the OSPF to exchange routes, but you don't really need them to populate in the routing table.
Yeah. So it's more like a customer prefixes that are not within. I'm trying to remove them within OSPF because that's actually what makes your size but huge, your LSDB be so big. So the idea was to reduce that size because also your consumption, you don't need to like enterprise grade equipment. And the budget also, that's something to take in consideration. That's why we came with a team. We came into this type of topology to review it. So it's helping, but again, still like it's still challenging. But how would you? Which approach would you take also if you were in that case?
So basically, I wouldn't uh, I wouldn't use the stub options in your network. And reason behind that is that if you're using your stub options, it's going to impact BGP heavily, because let's say, for example, you have your PE routers that only receives the default route. So what's going to happen is that your BGP peering will fail, because BGP doesn't really believe in your default route on the underlay to talk to
Yes.
other. It rather wants the specific route.
Yes.
So in your case, I don't know which vendor you're using, but I'll just use the Cisco term, and I also use
Okay.
the Huawei term as well. There
Okay,
is
fine.
a feature called prefix suppression.
Mm-hmm.
So what the prefix suppression does, let me go here. So let's say you have your MPLS core here, and you have your P's, etc. I won't draw lines. You get the idea. Okay, so say for example, your network here is part of area 0, right?
Yeah.
So the transit interfaces will be these ones here, these interfaces. So if you apply prefix suppression, it will say, hey, I do not need to advertise these the routes that are part of the transit. I'd rather advertise only the loopbacks, right? And then the other thing that I would recommend to save resources is to also change the network type to point-to-point to reduce the amount of LSAs that are associated that are required. So if it's point-to-point, you don't have to have DR and BDR all around the show, because it's going to kill your devices.
Yeah.
So
to comment on that, so on the access side, I don't have it's mainly point to point. And then on the DC side, that's the only way I use point to multiple broadcast. Reason being because I got two cores in the DC. So one is a DR, one other one is a BDR. So that's the only part. So wherever there's like a fiber, like a pop, wherever there's a fiber termination, then I will do broadcast back to a DC, just for that resilience reason.
So if I may ask you, excluding the network type, is your IP scheme slash 30s all around the show, or is it slash 24, slash 28?
So we tried to redesign everything. Obviously, it was both chaotic. So for the customer prefix, like I mean like a last mile, so we got like 2/20/21, which I'm injecting local one, and then I got the /22, which is just for management of your equipment at the node level, whatever you call, whatever device you got there. This is just for management purely. Then for point to point, we got the /30s. Then yeah, and some links. Obviously, when we use public, we do /31 or stuff like that.
All right. So what I will tell you,
and /29 in a DC, obviously for broadcast.
Okay, no problem. So what I would suggest, so all the options that I'm giving you with OSPF, I will regard them as short term, because now as you apply them, your setup is becoming more and more complex.
Yeah.
So I would rather say move over to ISIS. It's not resource intensive. It is layer 2, because it doesn't really care. So the database doesn't really store layer 3 information per se, like your OSPF database, but rather your layer 2 information as well. So short answer is, with a setup like that, long term, use ISIS.
Okay. And what is so far? I know you work with OSPF. What has been your most challenging or event like in your journey so far within the OSPF topic?
The most challenging part that I faced with OSPF is how the stubs are advertising the default routes. So I'm gonna give you this scenario. So I face a scenario where I have Nexus switches, and those Nexus switches are in a not so stubby area. And then that Nexus switch is connected to an upstream WAN aggregation. So that switch, that WAN aggregation, so basically you have your Nexus switch here, and you have your WAN aggregation here. And then in your WAN aggregation, you have your firewall, you have the static default route that's propagated in OSPF. So the challenge that I have faced here is that with the not so stubby area, also looking at the inside of the ACI network, is that when you apply the not so stubby, basically you are dictate, or sorry, with default route control, basically you are dictating that although I am receiving a default route from the WAN aggregation, I want to self-generate a default route and then send it through. But the challenge that I've seen is that when this WAN aggregation went down, the default route did not clear. There was a backup path here with a not so stubby. That backup path never kicked in because the default route with the no
Still on the table.
was black holing the traffic, and it was a huge problem. So a redesign is required, but we were required to apply a temp solution, which is tracking. It's not really recommended because you're basically defeating the purpose of having a dynamic protocol.
Yeah.
But because of the urgency, we had to apply tracking. So that's the challenge that I faced. That's number one. Number two, it is in the MPLS core. In the MPLS core, what I have done is I actually caused an outage. Oh my word!
Good to know. Good to know. We all been there. We still doing that mistake. All of us.
So I applied a totally stub area in the MPLS. So I had area 10 and area 20. They were both stubs. But the challenge is that although I have a default, they all have a default route. The BGP went down. It caused massive issues. Customers were offline. So we were required to roll back. And that's where the prefix suppression came into play. So that's the other challenge that I have came across in OSPF.
Okay. Cool. Let me give chance to others as well. But thanks for advice. I'll look into that.
Sure. Any
Okay.
time.
Cool. Thank you.
Any other questions?
Martin, concerning, just a follow-up on the question from Cyril, there is a comment in the question, in the chat, about summarization, how summarization can help to solve the problem that Cyril has mentioned. If you can just comment on that.
So IP summarization, basically it will reduce the routing table size, but what it won't reduce the link state database size. So based on the scenario, the challenge is not really the routing table size, but rather the link state database size with the amount of LSAs being propagated.
Agree.
Hope that's clear to Chris. That was the comment from Chris. I don't know whether I missed a discussion about the OSPF type 1 and type 2 routes, the external OSPF routes. If you can, maybe I missed it.
Oh yes. Oh yes, yes. My apologies. I was being a bit fast there. Okay. So with type 1 and type 2 routes,
Yes.
so I'm just going to draw a simple topology here. Two routers here. So let's say you have 10 loopbacks here and you have 10 loopbacks. You have applied redistribute connected, and then you've applied redistribute connected here as well. So when you apply it, and if you don't specify the seed metric, by default the external type will be type 2. So the type 2 says, I will keep the metric the same regardless of the hop count, right? But if you have metric type 1, metric type 1 says, I will expose the real cost to the destination. So metric type 1 is preferred over metric type 2, but you need to be cautious about that. From book terms, it dictates that it's preferred over metric type 1 is preferred over metric type 2, but it can introduce challenges based on your design. So I'm going to give you a set of designs where I will recommend the metric type 1 over metric type 2. So if you have two routers here as an example, and you have your WAN side, let's say it's your MPLS as an example. You have your core switches here running, and your OSPF is running here. I will recommend that technique of the metric type 1 over. So let's say, for example, you want him to be metric type 1 and him metric type 2. Then that way, you'll only see the route coming from this side, and then this one, it will just be an idle. But where to not use metric type 1 is when you have a data center with multiple links. Say, for example, this setup here. Let's say it's interconnected like this, and you have your head office being interconnected to your data center. So the problem here is that if you set the metric type 1, basically it'll still work. Let's say you are redistributing routes from the MPLS, and they are coming this side. And let's say this is head office. Let's say you have another router here that's also going to the MPLS, but you rather want the head office to be the preferred path. So if you use metric type 1, you will lose control of the route, because now the cost will keep on changing from time to time because of the nature of the seed metric. And you will also experience routing loops as well, which I have seen as well. So with those two options, they purely depend on how your network is designed, and apply them with special caution. So with OSPF metric type 1, the default seed metric is 20. So when it's 20, let's say you have 10 hops to a destination network. Regardless of those 10 hops, your seed metric will remain the same. And then one other thing that I have not mentioned in OSPF, and please do forgive me, is the default costs. So by default, OSPF auto-reference metric is 100 megabytes per second. So if you have a serial link or a T1 link, the cost will the cost will be 100 minus 1.566. So in total, you will get a cost of 64. If you have an Ethernet link, with an Ethernet link, you are looking at a cost of 10. If you have a fast Ethernet, you are looking at a cost of 1. If you have a gigabit, the cost will be 1 as well, 10 gig as well. So the challenge with this, if let's say you have fast Ethernet links, gigabit and 10 gigs, and your auto reference bandwidth is 100, your flow will become unpredictable. It will not be predictable. So it's rather best to change your auto cost, your auto cost, your auto cost reference bandwidth from 100 meg to a gig to make sure that the costs don't remain the same. All right, Martin, I hope I answered your question regarding the metric types.
Yes, that's very clear. Thank you for the response.
All right, are there any other questions?
Guys, you can unmute and ask a few questions. Yes,
Anele?
No, it might not be a question, Martin. Can you please touch a little bit on OSPF virtual links?
Oh, virtual links. Okay.
Yes. It's not a question, just, you know what I mean? Yeah.
All right. So virtual links. So the question is, what are virtual links used for? So before you apply virtual links, you need to understand the design behind it and the use case behind it and why you need it, and what are the limitations of the virtual links. So when it comes to OSPF virtual links, I'll just type here OSPF virtual links. So OSPF virtual links are used to allow an area that is not connected to a node that has a connection to area 0 to have network reachability. So that's the core purpose of your virtual links. So now let's start with the limitations of virtual links. So with virtual links, you are not allowed to use stub areas. You're not allowed to. And then the other limitation is that if your network is using that principle of you want your OSPF to auto elect a router ID, and you have virtual links, and let's say for some reason your switch reboots and then it comes back, and then the router ID changes, basically your virtual link will go down. So when you have the virtual link, make sure that the router ID is hard coded, not elected automatically. And then with the virtual link, it has a flag that it enables called the DNA or the do not age. The do not age, what it does, it says, okay, so I am connected to that area. So let me go to the topology here. So let's say you have 3 routers here. And let's say area 0 is here. And let's say here is area 1. And you have area 2. So basically the area that will be impacted will be area 2 because he doesn't have a leg to area 0 or a direct leg to area 0. So this will be this is where you will need to configure your virtual link. But when it does that, it's going to strip off this area 2 and then in the database replace it with area 0, but with a flag of DNA or do not age, meaning that the routes that are coming from this virtual link, they are originally coming from area 2, but because we're using a virtual link, they are not allowed to age. That's the fundamental reason of the DNA flag. Anele, have I answered your question there?
Thank you so much, man.
Cool. Any other questions?
Quick
Yes,
one. David. First. Can you hear me?
Yes,
yes.
I just want to ask if you used the L3 OSPF on top of L3 VPN. Can you maybe touch on that if you did you got exposure to that?
Are you talking about the MPLS L3 VPN?
Not forcefully MPLS, but you build like a tunnel, then you run OSPF on top of it, but they are 3 tunnel. So how would you advise such thing within your OSPF?
Okay, I understand. So, firstly, it depends on the tunnel type. So before I proceed, assuming that you are referring to 2 routers, are you referring to GRE tunnels or are you referring to IPsec tunnels?
I think in my scenario it was so obviously it was I think I did it on an IPsec and as well on a WireGuard tunnel and build OSPF on top of it.
WireGuard tunnel. That
Which is
sounds
more
like
like a advance of L2TP, something similar. So it's like a L3.
okay. So let me start with IPsec. So IPsec does not support multicast. It doesn't support it. So if you try to use it, your OSPF hellos will be suppressed because the technology doesn't support it. So it will rather be seen as a non-broadcast multi-access network, and your hellos will be impacted. So in that scenario, I wouldn't recommend OSPF. In that scenario, I would rather I would prefer BGP because BGP doesn't rely on broadcast or even multicast. And then with your L2TP tunnels, have I heard you correctly?
Yeah, you can call it LTTP or you can call or WireGuard. Yeah.
So basically, you are building a layer 2 tunnel for a customer.
Yes.
Okay. So with a layer 2 tunnel, it'll be built from loopback to loopback on the underlay on the service provider side. So in that case, running OSPF there will not be an issue, because the OSPF will be used as an underlay reachability for the loopbacks to be able to talk to one another, and then also with the with the L2TP, that's where you can now add that address family into BGP to allow it to export the layer 2 addresses. So your OSPF will just be an underlay. So that technology will be fit for purpose. Does that answer your question?
Yes. Yeah, because I do have such channel active currently, and the motivation was there's some scenarios where I couldn't get like a pure L2 back to a DC. So I was kind of like being forced actually when you get your L3 service, but you still wanna join your new router into your OSPF domain. I think that's where my motivation was.
Okay. So you can't, if your layer 2 session is not coming up, um, you might first want to check the source and destination loopback reachability, right?
Yes.
And
And
then
and what was interesting is what I did is that then I tried to hold like a VRF because your provider gives you, your L3 connection you're getting, it's on the main table. So you try to separate both by building VRFs and run your OSPF on a specific VRF because your provider doesn't allow that to go to cross their network.
okay, so all fair and well. Um, I will still say check your underlay reachability from loopback to loopback.
Okay.
Because your scenario is similar to an X connect, meaning a point to point.
Yes, it's a point to point, but the only difference is like it's running over a tunnel, and you got your primary connection with your L3 from a third party. But they couldn't. So what happened is that they couldn't deliver L2 to you, like a L2 circuit back to a DC. So you have to run like on top of the L3,
Yeah,
and
okay.
this I found that the only solution to make it work.
Sure. Okay, no problem. Any other questions? I know is Philistus here?
Well, let's take the question from David, and then I believe that should be the second last question. We can address to other questions in the group.
Okay.
Martin, what do you think? Will that be okay?
Yeah, sure. I'm happy with that.
Okay. So, David, you may ask your question.
No, thanks, Martin. Mine is not actually a question, but I promised to clarify something at the end of the discussion. And I think Eve did clarify it perfectly. I just wanted to just say it out verbally. Martin, could you please go back to your notepad where you had your your OSPF state machines, please?
Sure. Here.
Yeah, there. Okay. Yeah. So at the beginning, remember I had raised an issue regarding DR and BDR. Then there's also the concept of master and slave. And at what point of the OSPF state transition they occur. So DR and BDR is actually possible when we have broadcast and NBMA networks. That's where you have to elect a DR and a BDR. But in the case of a point-to-point connection, you don't need the BDR or DR election. So that point is very clear. So when it comes to a broadcast network, so the DR and BDR election takes place during the two-way state. Okay, but now after that state is done, remember we don't have two-way state in point-to-point or point-to-multipoint network types. So after the DRA and the BDR election is done, so we proceed to the exchange stage. Now here is where the master slave negotiation will take place, and that is basically to decide which router will start exchanging the database description. Remember they have to exchange the DDs. So this is where the master and slave takes place negotiation. This is at the extract stage, and this is important because we don't have two-way state in point to point. So therefore, from the init state we go to all the way to the extract. I think in point to point. So therefore, there are two different concepts, but they have a similarity in that the master router is actually the router with the highest router ID, and then the slave becomes the router with the lowest router ID. So they normally confuse, and I've seen this question a lot in exams, and it's important to know for that point if you're going to do the exam, and also in real life scenario, you need to know where master slave is done, and where BDR and DR is done. And lastly, a clarification that I wanted to make, not a clarification, but an addition, where you say that OSPF uses the multicast of 2224.5. It's also very important for us to know that where since we're talking about DR and BDR, where we have DR and BDR election, BDR and DRs do listen to the multicast IP address of 224.0.0.6. I think it's also very important for that to
you mean 5?
No, 6. DR and BDR uses .6. The others use .5.
Okay.
Yeah.
Okay. I hear you, man. And thank you for the explanation.
Thanks for the presentation, Martin. Really appreciate it.
Cool. Okay, so before we end the session, there was a scenario that I did promise that I'm going to show to you guys regarding the control plane policing, where if the permit TCP any when it's applied, when you're running OSPF and BGP, only the BGP will be impacted. So I think I'll use this time to demonstrate it. So if I go back to the topology, I went straight to this PE router that connects to the internet. So I will connect to the management box of the service provider side. All right. So I have this access list here, stipulating that this subnet is allowed to talk to this loopback on telnet and SSH, and then the unauthorized, it says permit, but on the policy, social policy map control plane, so on the unauthorized, the action is dropped. So then what I mentioned previously is that if I go to, before I apply this, I'll type in show users. So I am coming from this IP, just to show you where this IP is coming from. So I'll type in show IP root OSPF v3 201.255.7.6. Oops. Actually, sorry, it will be show IP root. So you'll see that it's coming from OSPF. So I'll go to the access list, extended unauthorized access, and I'll go to the access list. I'll remove 10, and I will remove 20. And in here, I will apply permit TCP any. So notice that because now my route is coming from OSPF, I did not lose connection to this router. However, what's going to happen is if I go to the BGP table, the enable will remain up, but I just killed the BGP updates. So now if I type in show TCP brief, so notice that I just impacted BGP. So here's the BGP here, but notice that now there's a finish wait, meaning that I have killed the session and I'm waiting for a finish update from this router, but it's suppressed because of the permit TCP any. So if I go there, notice that the packets are being dropped. But now if I go and clear, because if I don't clear, it will wait for the whole time. So I'll put in show IPBGP some VPN v4 or summary. Notice that now they are stuck on active. Nothing is happening, although I still have access to OSPF. So that's the scenario. And by the way, it's one of the scenarios that I faced as well, which was super complex. It gave me headaches. And I think it was, I forgot the gentleman's name, who was asking about the service provider design on OSPF. So if I go to show run section router OSPF, so this is the command that I'm referring to. So if I type in show IP route OSPF v3, so you will notice that it's only loopbacks that are propagating, but as for these ones, they are not coming from the MPLS, they're coming from the management. All right. And then mistaken, I also killed the control plane of the MPLS as well, which is TCP 646. So I'll go ahead and fix it. So I'll say no 10. I'll say permit TCP any. Tell TCP any. Oh, it's 20. Oh, what? TCP any. Oh, EQ. Telnet, and there'll be 22. So when it's like that, if I type in show policy map control plane, I will now start to receive traffic on the default class, which has implicit permit by default, which has the match any criteria. If I type in show MPLS forwarding table, now my control plane is working, and the BGP is working as well. So if I go to v4 or summary, so all of the neighbors are 100%. All right, so that's the scenario that I wanted to show you guys, that I was referring to in the WhatsApp group.
Thanks, Martin. I think it's clear.
You're welcome, David. Are there any other questions?
I haven't seen any other question in the chat, and I believe everyone should be okay. I know we've taken more time than expected, but thank you guys for being patient. Is there
Okay.
anything additional that you need to add, Martin, or we can?
I wouldn't say additional, but to say thank you for joining the session and making the time as well. And I'm also learning from you guys as well, because I'm also here to learn as well. So thank you for that. Thank you for the clarifications where I went wrong.
Yeah, I agree. We are always learning every day, and this is a good way to learn by also sharing the knowledge with the others and also getting to hear from them their thoughts, their way of understanding, which really help us to go deeper and deeper into these networking topics. I will open the floor to two guys who have comments. Anyone who has a comment about the session? Yes, Chris.
Hi, Martin. Just a quick question. So, in production, can we use OSPF as a routing protocol for GRE tunnel?
Short answer, yes. GRE supports multicast.
Okay.
Okay,
Chris, that is
thanks.
answered. Anyone with a comment? Yes, David.
Thanks, Martin. These sessions are very, very educational, and they are helping all of us here, and it's for free, unless someone is being charged. I don't know, but it's for free. So I was requesting
We are
I
sending
was,
the M-Pesa numbers.
I was requesting for the members. The only thing that you need to pay is your time being here, because I have seen the same materials being charged somewhere, and it's a lot of money. So I was requesting if it's possible, Martin, for complex or broader topics like OSPF, ISIS, BGP. Is it possible? Because 2 hours or 3 hours is not enough to go through all these things. Is it possible to maybe break them down and say, we will have theory on Saturday, for example, today, then the next time we have the lab, so that when we're dealing with theory, we can have enough time to ask questions and clarification. And then now when we're doing the labs, we have a better understanding of what is going on. So we just have to follow, and the labs do really take a lot of time also, so that we have enough time to do them. So my request is it possible to maybe break them into like two parts: the theory part, and one session, then the practical part, a different session.
Yes, I totally agree with that. Even theory, it's not possible to cover OSPF theory in one session. I think Martin has really tried to accommodate all the topics, but it's not possible, and that is a very good suggestion that we can adopt from the next session, because I have someone who is coming in for BGP, and I will talk to him and just align so that we can break the sessions into smaller manageable sessions that we can. Again, we need to accommodate different people. We have beginners, we have intermediate, we have experts, and I think beginners are wondering what is going on, because we were very quick to jump maybe to some other advanced topics. So I believe by breaking the sessions into smaller, manageable sessions of 2 hours, we can be able to cover more and learn more from the sessions. That's a good suggestion, David. We will consider it.
Yes. So what I thank you for that. So what I can say about OSPF. So from my personal experience regarding OSPF, OSPF is a 1 week topic from my view, because there's a lot of stuff being involved in OSPF. But the most important factor that I will say to all of you is OSPF is not just about understanding the configurations, understanding the timers and LSAs and all that. OSPF, when you approach it, you need to approach it with a design mindset. So approach OSPF as if you are a network architect. So it's design sensitive. So apply it with special caution. But yes, OSPF is a 1 week session. It's quite a big topic, and by far it's the most complex interior gateway protocol that I've seen thus far, unlike EIGRP.
I think we've lost you. We're not able to.
Oh,
If you are
can
still
you?
speaking or you've.
Yeah, I'm not sure if you caught everything that I've mentioned.
The last few sentences, I think we missed the last few
Oh,
sentences.
oh, sorry. I wanted to say OSPF is a 1 week session. One week topic. I meant to say. Um, and the theoretical part of it. My advice is, if you really want to understand OSPF, go to the heart of it, which is the RFC. So most companies are using OSPF version 2. It's a few that are using version 3, but I do advise that you guys use the RFC 2328, which explains OSPF in full detail. Can you guys hear me?
You dropped again.
Oh my goodness.
Yeah, we heard about the RFC number, and then we lost you again.
Oh snap. Okay. But I see Michael's hand is up,
Michael and Guma
and Guma, yes.
and Chris. Can we start with
Yes.
Michael? Or okay, Goma, you can go. You already unmuted.
Okay. Thank you for the floor. I want firstly to thank you for this session. I really appreciate it. As I said at the beginning, that this is my first time to join the meeting. Since I was added in the group, I'm getting the notification, the message in the group. But in terms of the meeting, this is the first one. And my first question, I want to know if we are going to have a meeting every weekend, every Saturday. This is my first question. Then the second question is this plan, is this session plan to be maybe discussed step by step, or the topic will change per weekend? Then the last question is it possible to maybe ask on advice? I don't know, maybe by email or by WhatsApp from you, to get some advice for people who want to do some international certification in terms of best practice and how to do. Thank you.
Okay, I got the first question. clearly. We've scheduled this session to be after every 2 weeks. Remember, it takes time to prepare, and some weekends we also need to attend to some other personal issues. So the sessions will be after every 2 weeks, and the topics will keep changing. They are not fixed. Last time we talked about subnetting. Today we are talking about OSPF. Next time we could be talking about BGP. We are just cutting across. Sometime later we'll be talking about maybe the WDM. We'll be talking about even some soft skills. We can bring in someone to guide us. How do you make your CV? Just some soft skill that we may also need as network engineers. What was the last question? I think I missed the last question.
The last question was about people like me. This is my case now. I want to get a certification from CCNA. I want to know if there is a possibility maybe to discuss with you in terms of getting some advice. What is the best practice to perform better and to finish the training end to end and get the international certification from Cisco, for example?
Okay.
Maybe
Yeah,
with other products.
I get it. So for the certification, I believe many people on the platform. Currently, actually, we are more than 1,000 people on the platform, and I believe many of us are taking different certifications or are preparing for different certifications. Some are preparing for Huawei, some are preparing for Juniper, some are preparing for Nokia, Cisco. So it's an open platform. You can ask your question on that platform about the certification. Someone will pick it up, or you can reach out to me directly. I will be glad to support you.
Okay, thank you. Thank you so much. I get good answer and clear answer on my three questions. Thank you.
Okay.
Appreciate.
Michael? Michael, your hand is still up. Or anyone else, the last person? Anyone who has a comment? Yes, Michael, I see you are unmuted. We can't hear you. Okay, let me take this opportunity again to thank Martin for taking us through this session. I think he really took his time to prepare well for the session and even the lab. And he has been able to take us through a lot of things about OSPF in shortest time possible. Martin, you're still welcome to come back with maybe a specific topic on OSPF. I know we were in rush, but if you could still take on small topics and come back and take us through those topics, we will appreciate, so that we can now accommodate everyone, as Michael has, as David has mentioned. If we can have smaller topics to accommodate everyone. I also want to appreciate all of you who have joined the training today, and we will be having many more sessions. Again, you just need to show up, you just need to participate, interact, ask questions, and let's create an environment where we can all learn and empower each other. That is the goal of this platform. I hope that that's clear, and that is it from me, unless there is any additional point, A or B from the team. Any A or B before we call it a day, so that you guys can enjoy your weekend?
So my question before we end.
Yes.
My question, I need a clear view of what are the struggles of OSPF, not just from a theoretical point of view,
Yes.
but from a production point of view, where to use OSPF, where not to use OSPF. So if you can share that with me, then I'll know what to prepare for.
Okay. I feel I can reach out to you separately, and then I can create a questionnaire and share on the platforms so that we can collect them from the guys who are facing the problems, and then we can see how we can support them.
Okay.
Thank you. Chris?
Yes, I have a question. So about OSPF, and I do a lot of labs on OSPF. So my biggest question is about stub areas, because I know that we use stub areas to shrink to reduce LSDBs, but what is the other use? Only to reduce the LSDB, or there are other use? Thank you.
Yes. So OSPF stub areas are used to shrink link state databases. But the principle here that is required is, which problem are you trying to solve? Are you trying to shrink your routing table, or are you trying to shrink your database? And reason behind that is that it's very important to apply a solution that is accurate to the problem that you're trying to solve. Chris, does it answer your question?
Okay. Yeah. Thank you.
Okay, guys. Thank you so much for showing up. I hope to see you again in our next session, which we will be announcing on the WhatsApp group and the other platforms. Have a good weekend and continue learning and labbing also.
Thank you so much, Matt.
Thank you.
Cheers.
Thank you. Have a nice weekend too.
Have a good
Thank you,
weekend
everyone.
too.
Bye.
Thank you.